Imagine gold, platinum, and rare metals worth trillions, just floating in space, waiting to be claimed. Science fiction, not anymore. Space mining is no longer just a wild dream. It's a real, fast-approaching industry that could change the world. For centuries, humans have dug deep into the Earth, searching for valuable resources. But what if the biggest treasure trove isn't underground? What if it's out there, in the vastness of space, on asteroids packed with metals rarer than anything we have on Earth? Big companies, billionaires, and even space agencies are racing to tap into this new gold rush. The technology is advancing, the money is pouring in, and the stakes, astronomical. But how does space mining actually work? Who stands to profit? And could this be the key to a future where humanity expands beyond Earth? Let's dive in. For most of human history, all the resources we've ever used came from one place, Earth. Every ounce of gold, every bit of iron, every drop of oil was extracted from beneath our feet. But now, for the first time in history, we have the technology to look beyond our planet. The idea of space mining isn't new. Science fiction writers have imagined it for decades, but in the last few years, it's become less of a fantasy and more of a serious industry. Investors are pouring billions into research, and space agencies like NASA and private companies like SpaceX are laying the groundwork for a future where mining asteroids is as common as drilling for oil. But why space? Why go through all the trouble of launching rockets, sending robots, and extracting materials millions of miles away? The answer is simple. Resources on Earth are limited, but in space, they're practically infinite. Take platinum, for example. It's one of the rarest and most valuable metals on Earth, used in everything from electronics to medical devices. If we suddenly had access to the platinum in just one asteroid, it could be worth trillions of dollars, more than the entire global economy. And it's not just platinum. Asteroids contain gold, nickel, iron, and even rare Earth elements, which are essential for making smartphones, batteries, and satellites. Some experts believe that a single asteroid could hold more metals than have ever been mined in all of human history. If that sounds like science fiction, consider this. We already know where these resources are. Scientists have mapped thousands of asteroids near Earth, and some of them are practically floating treasure chests. Take 16 Psyche, for example, one of the most famous asteroids in our solar system. It's estimated to be made almost entirely of metal and could be worth $10,000 quadrillion. That's a number so big, it's almost meaningless. It's more money than has ever existed. But before anyone starts cashing in asteroid checks, there's a catch. Mining in space isn't easy. There are massive technical, financial, and legal challenges, and the first companies that figure out how to do it successfully could become the wealthiest and most powerful in history. So, who's leading the race? Which companies and countries are investing in this future gold rush? That's what we'll explore next. The real question is, what's actually up there? And the answer is pretty mind-blowing. Asteroids, those small rocky bodies floating in space, are much more than just space debris. They're rich in materials that could change everything. Imagine mining a small asteroid and pulling out more resources than Earth has seen in centuries. Sounds like something out of a sci-fi movie, right? Well, in some cases, it's true. These asteroids hold materials that are worth their weight in gold. Literally. Let's start with metallic asteroids. These are asteroids made almost entirely of metal, like 16 Psyche, which we mentioned earlier. It's the size of a small planet and contains vast amounts of iron, nickel, and possibly gold. Scientists believe the asteroid could be the exposed core of a planet that never fully formed. In fact, it's thought to be a relic from the early days of the solar system, kind of like an ancient treasure chest that's been floating in space for billions of years. Then, there are carbon-rich asteroids. These are the ones that are packed with materials like carbon, water, and nitrogen, ingredients for life itself. They might not have the glimmering gold of metallic asteroids, but they hold the key to building things here on Earth, or even supporting life in space. Water, for example, is an incredibly valuable resource for long-term space exploration. With water, we can create oxygen, fuel, and even grow food. So, asteroids are a treasure trove of metals and other essential materials. But just how valuable are these resources? Well, the numbers get crazy fast. Let's look at platinum. one of the most valuable materials on Earth. In one small asteroid, there could be more platinum than has ever been mined on Earth. A single asteroid, such as 511 Davida, contains enough platinum to satisfy the world's entire demand for over 100,000 years. Now let's talk about gold. While gold is often seen as a symbol of wealth, its true value lies in its rarity. On Earth, it's difficult and costly to extract, but out in space, gold can be found in nearly every metallic asteroid. Even if we only manage to extract a fraction of what's out there, the impact on the global economy would be huge. But it's not just about the well-known metals. Some asteroids contain rare Earth elements, the building blocks of modern technology. These include materials like neodymium, used in everything from electric motors to wind turbines, and yttrium, which is critical for making high-tech electronics. The demand for these materials is skyrocketing as technology evolves, and space mining could help meet that demand. In fact, Earth's supply of rare Earth elements is running low. Countries are starting to fight over the resources, which makes space mining even more appealing. If we can get these elements from asteroids, we could solve one of the biggest challenges facing our tech-driven world. But while these resources are out there, it's not all just about raw materials. Asteroids also hold scientific clues about the early solar system, how planets were formed, where life might have originated, and what conditions existed billions of years ago. Mining these asteroids could unlock secrets that would rewrite our understanding of the universe. So, what does that mean for the future of space mining? The potential is enormous. There's a wealth of precious resources waiting to be harvested, but how do we actually get them? That's where the technology comes in, and it's evolving at an incredible pace. Now that we know what's out there, the next big question is, how do we get it? After all, we're talking about mining asteroids. Objects that are millions of miles away, floating through the vacuum of space. How do we land on them, extract resources, and then transport them back to Earth? The answer lies in cutting-edge technology, from spacecraft to robots, and even artificial intelligence. Space mining might sound like science fiction, but the tools to make it a reality are already being developed. First off, we need spacecraft capable of traveling to these distant asteroids. Thankfully, the technology for this is already in place. NASA's OSIRIS-REx mission, for example, successfully visited an asteroid called Bennu and collected samples. While it wasn't a mining mission per se, it proved that we can land on asteroids, collect material, and return it to Earth. This is huge, because it shows that the basic concept of asteroid mining is technically feasible. Now, imagine sending a spacecraft like OSIRIS-REx to a metal-rich asteroid instead of Bennu. The spacecraft would need to be equipped with specialized mining tools. This is where the real innovation is happening. Several companies are already working on prototypes for mining systems designed specifically for asteroids. For example, Deep Space Industries and Planetary Resources are developing robotic mining systems that could extract materials from asteroids remotely. These robots would use tools like drills, lasers, and even harvesting devices to collect metals. Robotic mining is crucial because sending humans to asteroids is still far too risky and expensive. Robots can operate autonomously in harsh space conditions, where communication delays make real-time control nearly impossible. These robots would be programmed to identify valuable resources, harvest them, and send them back to Earth or to other space stations. In addition to robotics, artificial intelligence, AI, is playing a big role in space mining's development. AI can be used to optimize the mining process, determine the best methods for extracting materials, and even analyze data from the asteroid to decide which areas contain the most valuable resources. In short, AI could become the brain behind space mining operations, helping teams make quick decisions without relying on slow human input from Earth. But let's not forget about propulsion systems. Spacecraft need efficient engines to get to the asteroids and transport materials back. Currently, chemical rockets are the most common propulsion method, but they're not ideal for long trips to distant asteroids. That's why companies are exploring ion thrusters and nuclear propulsion as alternatives. These methods offer greater fuel efficiency, allowing spacecraft to travel longer distances with less energy. And there's one more major advancement that could change everything: 3D printing. In space, materials for building equipment are scarce and expensive to transport. But with 3D printing, we could manufacture mining tools directly on the asteroid using resources found there. Imagine landing on an asteroid, setting up a 3D printer, and printing mining equipment on the spot, instead of having to bring everything with you from Earth. This could drastically cut costs and make space mining much more efficient. As the technology continues to advance, we'll start seeing more and more missions focused on testing and refining these tools. NASA, for example, is already planning missions to mine asteroids in the coming decades. They're testing out robotic technologies that could be used to grab a sample of a space rock, and they've partnered with private companies to develop mining systems for future missions. The big question is, when will space mining become commercially viable? It's hard to say, but all signs point to the next few decades being a turning point. As these technologies mature and the cost of space travel decreases, we could see the first real asteroid mining missions happen in the 2030s or even sooner. And when that happens, we'll be standing on the edge of a whole new frontier in space exploration and resource extraction. So, while the idea of space mining might sound like a far-off dream, the technology is here, and it's advancing quickly. In the next section, we'll take a closer look at the economic implications of space mining, how it could reshape industries, economies, and the global market. We've talked about what's out there and how we might get it, but let's get to the real game changer, the money. Space mining isn't just about exploration, it's about unlocking an entirely new economy. Right now, Earth's economy depends on a finite supply of resources. But if we can tap into space, we're looking at trillions, possibly quadrillions, of dollars worth of raw materials. Let's put that into perspective. The global mining industry is worth around $2 trillion a year. Meanwhile, a single asteroid could contain more platinum than has ever been mined in human history. If companies successfully bring these metals back to Earth, it could crash commodity prices overnight. Take gold, for example. If an asteroid packed with gold were mined and brought back to Earth, the sheer increase in supply could send gold prices plunging. Some experts believe that if asteroid mining really takes off, the idea of precious metals might disappear entirely. Gold, platinum, and rare earth elements could become as common as iron. On the flip side, this could fuel new industries. With an abundance of rare materials, technology could advance at an unprecedented rate. Electric vehicles, renewable energy, and high-tech electronics could become cheaper and more accessible. And then there's the space economy itself. Mining operations could lead to the creation of off-world industries, including space manufacturing and permanent space settlements. Instead of bringing everything back to Earth, future companies might refine metals in space and use them to build massive space structures, like habitats, refueling stations, or even spacecraft for deep space travel. Governments and corporations are already investing heavily in this future. Countries like the US, China, and Luxembourg are drafting space mining laws to regulate how resources will be claimed. Private companies like SpaceX, Blue Origin, and Deep Space Industries are preparing for a future where space mining is a reality. But this raises big legal and ethical questions. Who owns space resources? If a company lands on an asteroid and mines it, do they own everything they extract? Or do these materials belong to all of humanity? Right now, international space law is vague. The Outer Space Treaty of 1967 says no country can claim a celestial body, but it doesn't say anything about private companies. This is a legal grey area that will become a battleground as space mining becomes viable. And let's not forget the risks. Mining in space is incredibly expensive. The cost of sending a single kilogram into space can be upwards of $10,000. Companies investing in space mining could spend billions developing technology, only to fail due to technical challenges, funding issues, or legal barriers. Still, the rewards are too big to ignore. If a company successfully figures out how to extract and process materials in space, they won't just be rich, they'll shape the future of humanity's expansion beyond Earth. We are standing at the edge of the next great frontier. Just like the gold rushes of the past, space mining promises untold wealth, adventure, and opportunity. But instead of panning for gold in rivers, we're chasing metals in the vacuum of space. The first company or nation to successfully mine an asteroid could reshape global economies, advance human technology, and even lay the foundation for life beyond Earth. The technology is advancing. The money is flowing in. The legal battles are heating up. Space mining isn't science fiction anymore. It's the next step in human progress. The question is no longer if we'll mine space. It's when.